Sorry about that, everybody. Good evening. Also, apologies that we had to start late. I was transitioning from a different interaction. I wanted to start off with two announcements. So first, I wanted to propose that we sort of like have a very short interaction to catch up on the lost hour or so. Well, it's less than an hour really. So I was proposing that we have another session tomorrow. I'm happy for us to start probably somewhere around 17, and then we should be done by, if we start at 17, we should be done around 18, maybe 18:30 or something. So that's that. And then I know there are a number of you that probably were reaching out to me regarding admin-centric issues. I was away attending the ICTAS event. I believe I had mentioned this. In fact, it's one of the reasons why I suggested that we move our Monday interaction to today, because it turns out that on Tuesday I was facilitating some training session together with Professor Kaleji from the Copperbelt University, and so on Monday we were actually busy preparing for the event itself. So apologies for that. I looked at your timetable and noticed that there was an opening, so I figured why not take advantage of that. So for those of you that had reached out to me, I think there are a few of you that had reached out to me regarding admin-centric issues. I'll be looking at those things beginning this weekend, because I only arrived last night actually, so I haven't really had a chance to sort of like catch up on a number of things, but we'll sort out those issues by next week. All right, so other than that, so we're going to continue our also a lot of things here. I should have probably added them to the slides as announcements. There was a query regarding the statistics course. I think there was a question as to whether those that have done the stats course are supposed to do this course. My immediate reaction was that if you are taught by the same person and you did that course, we consider that to be an undergraduate level course, right? So I'm not really sure what sort of content is being covered, but the expectation is that what you're doing right now is graduate level content ideally. So some things, or perhaps most of the things, may actually have striking similarities with what you did, but you're supposed to enter into the course nonetheless. For now, but I did mention that I would get clarification. And again, because I was away, I haven't been able to do that, so I'll be reaching out to you next week, ideally. All right. Unless if there are any questions about what we've probably done so far. I don't know if it's the one here, but I hope. Are there any questions regarding what it is we've done so far? Okay. It's a good thing we took a long break here. At least people have had the chance to digest some of the things that we did. By the way, I didn't even ask if you're able to hear me. I'm just assuming you can hear me and just fine. Thank you.
Yes, we can hear you.
Beautiful. Thank you so much, colleagues. So we're going to continue our discussion of lecture series number 2, and we've actually decided to dive into Python, right? So if you remember, when we met last time, we got as far as the part where we were discussing. So we discussed quote unquote variables, right? In particular, this whole notion of identifiers. How they're named and all those things. And as a reading list, we asked you to go and read PEP 8, right? So that we have a better sense of what identifiers are all about. This we did. And then after our discussion of identifiers, we zeroed into our discussion of comments. And I think this is where we ended ideally. Now, just to maybe remind us about so-called identifiers, I don't know if this is, we probably didn't really touch on best practices, but I told you to go and look at that reading list. I'm hoping that that people had that people have had a chance to appreciate best practices when it comes to readability of Python code. Okay, but ultimately, what you want to ensure is that as you're writing these programs, and you notice we'll soon get to a stage where we start doing more complex things, not writing one-liners, right? But you want to make sure that you get used to this notion of using meaningful names for variables. Okay, this example I have here, like var underscore student name, signals that the variable is going to probably hold some variable that will represent a given student. Okay, now you notice here that that name is probably more readable and more meaningful than the alternative var underscore sn. Sn can be anything, serial number or something like that, right? So you want to make sure that you do that. In some instances, abbreviations are appropriate because you wouldn't want to have very long variable names. Okay. Yeah. Anyways, and I don't know if the PEP 8 Python enhancement proposal PEP 8 mentions this. I have to look at it. I can't really remember the limit here of your variable name. So in other words, can you have something like var student name from UNS or something like that? In other words, what I'm saying is, can we do something like I'm just going to go here and just activate my environment for this course, and then in essence, you know how we're saying we can have something like var party is equal to upnd or something like that, right? And then we check the type var party. Can we have a variable like var political party name for the current, this is weird here, party in the Republic of Zambia, a country, this is weird here, located in Africa. Like this is in Africa, right? This is a variable, right? And I'll say upnd, right? It works, right? I mean, you wouldn't obviously create a variable like this because every time you're wanting to refer to this thing, you'd have to, kind of like write the same lengthy name ideally, right? So brevity here, there's got to be a balance between, how descriptive a variable is, and also notice how it works, right? How descriptive it works here. How descriptive it is, and also like just how complex a variable is ideally, right? So you want to make sure that the names are meaningful, obviously. For multiple words, the recommendation, I think you saw this in the PEP 8, is that if you have multiple words, to increase the readability of the variable itself. And this is usually for other programmers, other people that are going to read your programs, but also for you, right? Because it turns out that when you write a computer program, it's usually the case that at some point in the future, you'd refer to that program, right? So best use underscores to separate names, like var underscore student name, or var underscore student ID, or student identifier, or computer number, or something like that. Again, another best practice, most of these are lifted from PEP 8, really, is to use lowercase with underscores, right? Preferred. Now, best practices don't mean you have to adhere to these things. You can do your own thing. For instance, you probably find some people writing things like instead of var underscore student name like this is equal to or something like that. What they'll do is they'll just say student name, right, is equal to Kalenga. It's all the same thing, right? It's just like it's convention. It's I mean, you get to decide how exactly you'd want to kind of represent these variables, if you will. But that's okay also. What perhaps may be interesting here is to look at the actual best practices, is it? If I go into the things that I've installed, the libraries that we've installed, right, in my environment, the inside packages, and then if we go into Python pandas, right, and we open, I don't know what we're going to open here, maybe we open in core, we go in core, and then we open, let's say, just one of these module files, the .py files, maybe indexing or something looks weird here, nice. Well, you'll notice that as the programmers were writing this module file, there's an interesting way in which they're naming some of these variables, right? Let me see if I can, I don't know if I'll be able to find, these are all doc strings here. We'll go up to bottom here. Yeah, well, I guess it's fine, lowercase, right? They're abbreviating, obj here is an object, you know. There's some usage of underbars here, but yeah, so yeah, so looking at what other people have done is usually a nice way of trying to decide how you're going to name your variables, but that's fine. That's fine. Nobody cares about this. Again, I'm just showcasing what perhaps I would call good names, right? This is based on PEP 8, Python Enhancement Proposal number 8. If you compare, if you compare the var underscore student age is equal to 20 and var underscore private is equal to 42 here, you notice that the variable names here are somewhat descriptive, right? They're easy to follow. But look at var underscore second place. I don't know, right? You're starting the name here, assuming you're separating the different words here with an underscore. You're starting the name with a 2. This will work, by the way, but we're just saying it's a bad name. We're not saying it's syntactically incorrect. You can have var underscore second place. This will work, right? Sorry, is equal to this. This will work, right? It works like this. What doesn't work is if you say second place is equal to Kalenga or something like that. This will fail. Is it syntax error like that? Okay. So we're just saying here it's a bad name, bad variable name. This is also var if is horrible, right? Because if here is a reserved word, is it? You want to try as much as possible to stay away from including reserved words in your variable names idea, unless if it's absolutely necessary. And then the last one is wrong. It's a syntactically incorrect way of defining a variable name or an identifier because there's a hyphen, is it? The only punctuation allowed is the underbar or the underscore. So if we have var underbar my name is equal to John, this will fail. It's a syntax error. You know, the interpreter tells you syntax error and gives you a bit of descriptive information also. Okay, so hopefully this kind of gives us a bit more perspective in terms of identifiers. Just a quick recap here, and then we had a discussion of comments, you know, one-liners versus doc strings. Is it use a hash or triple quotes? And the interesting thing about the doc strings or triple quotes is that you can either have 1 2 3 1 1 2 3. This is valid. This is a valid comment. Multi-line comment. What else? Triple quotes, triple double quotes, right? this is also a valid multi-line comment. So this works. What you just want to make sure is that you're actually you're actually specifying pairs of these three triple quotes, right? Okay. And also remembering comments using triple quotes here is that when you're quoting stuff, right, in text, like he said, or say Elpiri said Python is easy or something like that. I mean, when we're writing this grammatically, this is correct as well, right? We can have like single quotes as well. Okay, so that's neither here nor there. That's pretty straightforward, I guess. So and then we had eased our way into this whole notion of basic data types. Okay, we started off by reminding ourselves that variables do not require an explicit data type. It's unlike other programming languages. So the idea behind the data type is it specifies the type of information that you're going to be storing in the variable, the type of information that is going to be held by the variable, right? And we see here that for the basic primitive data types, we have whole numbers called integers, okay? We have decimals, which are called floats, floating point numbers. And then we have strings, yeah? And then we have booleans. It turns out that a combination of all of these different data types will allow you to write instructions that you then issue to the computer in the form of a computer program. Like for instance, I could say I'm going to write a program that will enable me to compute the GPA scores for students at UNZA. The things I'm going to be playing around with really are just floats, floating point numbers, strings, right? Because I'm computing credit scores associated with the different courses and all those things here. Okay, so the question really is, so these are the basic, data types in Python, but what are they all about, right? What are they all about? Well, it turns out, we're going to start with numbers. It turns out that I'll ask our colleagues to maybe unmute ourselves here, because if we can manage to unmute ourselves here, there's quite a bit of feedback coming from out there. Trying to see if I can. I don't know why this is. I don't know why this is. Mute, that would be fine. Thank you. All right, so we're going to start by, because you can group these things, right? We'll start with numbers. So there are two types of numbers in Python, okay? You have so-called whole numbers. So these would be like positive whole numbers or negative whole numbers, and also zero, right? The thing that is in between here. Most of us have some math background, but also we did this, I guess, in primary school or something, when we were looking at negative, positive numbers, whole numbers, and all those things. So there are two types of numbers. There are integers, these are whole numbers, positive and negative, right? And then we also have so-called floating point numbers. They're called floats in the Python programming language. So you are looking at any type of number that has a decimal point. In other words, think about these things as numbers that you'd use to perform computations, like computations that involve money, for instance. So if you're writing a computer program that is supposed to compute things like pay or something like that, you'd have to work with floating point numbers, is it? Because monetary values are usually in decimal points. 14 kwacha 15 way or something like that. So 14.50. Okay. And a nice way of trying to confirm the type of number you're dealing with is to use the type built-in function. So you create a variable here, like I'm going to call this pass, var pass mark, right? Var pg pass mark. And you know, a pass mark here is 50, so I can define this as an integer value, right? And the mere fact that I've defined this as a whole number, the 50, signals the fact that this is an integer. Okay. What else? I could say price of, I don't know here, but var Lusaka basic needs and nutrition basket is equal to 11,345 kwacha 15 well, something like that. If I check the type of this, Lusaka BNNB is going to be a float. Okay. Notice what Python does when you use the type built-in function to check the type of the variable is it returns int, not integer, right? Int, int. It's short for integer, right? This tells you the class associated with the type. In this particular case, it's integer type. Okay. Yeah. So there's something else that's obviously interesting about numbers. So both integers and floats. You can essentially perform arithmetic operations. Okay. You know, I don't know if the math experts in the room are able to tell us the difference between arithmetic and mathematics or something like that, right? You know, I don't know. What is the difference? What is arithmetic? Apparently, I don't know. Colleagues, what is arithmetic? I don't know. But anyway, so you can perform arithmetic operations with floating point numbers, floating point values or data types, and also integer values or data types. Okay. So for instance, we're saying we can add numbers. Right? It's pretty straightforward. So given two numbers, in this particular case 10 and 3, right? If we define a variable var underbar a and assign it a value of 10, which is what we're doing here, right? Var underbar a is equal to 10, and we define another variable var underbar b is equal to 3, and we add those two variables. What we expect is we're going to get the result of adding 10 and 3, right? So we'll get 13. Okay. The interesting thing here is that the signs, right? You can use different signs as well. So var underbar a, we can say this is negative 10. Var underbar b is equal to, this is negative 3. What we're saying is we can add these, right? We can add these, say print var underbar a plus var underbar b. In essence, what we're doing here is we're saying we want to add negative 10 plus negative 3. So we're going to get negative 13 here. Okay? So this the same kind of rules, right, that you use in arithmetic or mathematics actually apply here as well. Okay? We can also do subtraction, right? So again, if we get the same values, I've defined slightly different values in my example here, deliberate, right? If we have negative 10 minus negative 3, we know what this means, is it? It's almost like it's minus 10 plus 3, right? So we expect to get what? When we minus here, negative 7, right? So it's like minus 10 plus 3 ideally. These negatives cancel out, okay? Multiplication is the same thing, right? What you notice here is that in as much as the same kind of rules apply in mathematical operations, you want to pay particular attention to the signs that we're using, the operators, right? No, the operations, right? So the plus operation is used to add, the minus is used to subtract, the asterisk, not an x, but the asterisk is used to multiply. Yeah, you're going to come here and say, well, we want to get the result of multiplying negative 10 and negative 3, right? I'm going to use asterisk. Yeah, I expect to get, yes, you guessed it right, positive 30, because the negative values cancel out. The same kind of rules, right? Okay. Interestingly enough, when you are dividing, right, you use a forward slash, is it? Forward slash, right? Forward slash, like the thing you use when you're specifying your, I don't know what you call it here, your NRC. Again, this is negative 10 divided by negative 3, it's a positive number, right? Because the negatives will cancel out. So it's 3.3333333 all the way, right? If that makes sense. Okay? Now, an interesting point about division is that it's always going to return a floating point number. In fact, even when you divide whole numbers, 4 divided by 2, I'll get a floating point number back. I'm not getting an integer. It's an interesting property that you want to appreciate here. So every time you perform division, you get a floating point result, even though the operators are both whole numbers. Okay, when you're multiplying, or they are integers, right? When you're multiplying integers, you will get integers. When you multiply an integer and a float, the one with higher precedence takes effect, right? So if I say I'm gonna multiply, I don't know here, 1 times 1.5, the answer is going to be 1.5, which is float. Okay, you say, well, but why is that? 1 plus 1 times 3.0, let's say 2, which is an integer, multiplied by 3.0, which is a float. I'll get back a float here, 6.0, right? Because float it takes precedence. It's more important, ideally, in the hierarchy. Okay? There's more operations, that you can use here when you're performing arithmetic operations. Like, for instance, you use the double forward slashes. When you use the double forward slashes, you get back, it's more or less like a flow, right? The whole number. So look at this. 5 divided by, I don't know what 5 divided by 2 is. It's 2.5 here, but if we do double forward slashes here, we're going to get back 2, right? We are saying we get the whole number here, this one here. I guess, I don't know. It turns out that some of these things are important, right? Depending on, there's certain interesting, things that you may be working on that may require that the logic gets the whole number, right? Once you do a division. Is it? I don't know if this is making sense. How about 5 divided by 3? 5 divided by 3, 1.66. And then if you do double, yeah, it's a flow. Okay, the flow here is like, there's no rounding off, if you notice. I don't know if you noticed this. Maybe not. What else can we do? We can use the modulo operator, which is a percentage sign on your keyboard. What that does is it returns the remainder. Okay, so it's like it assumes you're dividing the two operators, but what you get back is the remainder. And so it's like if you want to divide 5, what is 5 divided by? 5 divided by 2 is 2.5. However, if we do 5 modulo operator, we're going to get 1. Right? I don't know if this is making sense. It's like this may be confusing actually. We're saying 5 divided by 2 is going to be equal to what? It's 2. Remainder, the remainder is not 0.5, it's remainder 1. Right? 2 goes into 5 2 times. The remainder is 1. And it's making sense also. I don't know what else also we can use here. I'm trying to look for a nice number to divide. 3 divided by 5. It's like, 9 divided by 5. 5 into 9 is 1. 5 goes into 9 1 time. The remainder is going to be 4, right? 4 apparently. So what we expect when we do the normal division, yeah, 9 divided by 5 is 1.08, is it, or something like that. If we do if we want to get the floor, what we're going to get is 1, right? But when we do the modulo operator, we're going to get 4, right? Because 5 goes into 9 one time, remainder is 4. Maybe tricky here, but confusing at times, but you know, with time you get used to these things here. Also, there's some interesting things here, like if you wish to get the result of raising a number to a power, for instance, 2 raised to the 8 here, a bit depth of 8. 2 raised to the 8, what we're saying is you use 2 asterisk. Let's get confused here. 2 raised to the 8, right? 256. Or 2 raised to the 3, I guess, is easier, right? 2 times 2 times 2 times 2 times 2 times 2 is like 8. Okay? If that makes sense. In some programming, I don't know which programming language you can do that here. 2 raised to the 3 or something. But in here it's asterisk. All right? Hope you've kind of taken a note of that. I hope this is making sense. I think they will make all of this will probably make a lot more sense when you're playing back the notebook, which I shall share, but also you want to experiment with these things yourself. Okay? I don't know if any thoughts or questions. Easy stuff here. Okay. Yeah, I'm just showcasing. I'm just. By the way, this is a bitwise operator. In case you're wondering, I don't know. It's a bitwise operator. So when you're working with things like it's like your XOR, right? It's not really your classic arithmetic operation, if you will. All right. So I have some examples here, right? Where I'm dividing, 7.5 here divided by 2, and we see that we're getting 3.75 here, which is exact result. We're dividing 7.5 by 2, right? 7.5 divided by 2. In fact, all of them are floating point numbers. We get 3.75, right? However, when we do floor division, which is 2 forward slashes, it's more or less like we're truncating this part here after the decimal point, right, to get the result. Although the result is still going to be a floating point number, is it? If this is making sense. I don't know if there's any other kind of like questions about. I don't know if there are questions about this. Yes, please.
Good evening, Doc.
Yes.
The question that I have is concerning the same numbers. Are we able to extend the processes to other types of numbers like complex numbers?
Well, implicit, we'll talk about this tree when we look at. Well, I don't know if we're gonna. We discuss. You must remind me when we discuss modules, right? It turns out that there's a way in which you can actually work with complex numbers, ideally, right? I think I don't know if I have. There's a math package here. There should be a way of specifying of specifying this using the math package. I'll have to look at this. I don't know. I haven't really worked with complex numbers a lot, but how example would be what 4i? How do you say? Please, the math majors. 4i is a complex number, right? Well, how do you specify complex numbers in ideally in the what do you call this? Is it how do you specify complex numbers?
a complex number has got two components.
Uh-huh.
It has
There we
the
go. Look at
imaginary
this.
part,
It has what?
the imaginary part as well as the real part.
Uh-huh.
So it
So
becomes complex.
so this is the imaginary part, right, J?
Yeah, so 4J is imaginary.
Okay, so if I have something like 2 plus 4J here,
Yeah,
the thing is
it
which one
becomes
is
complex.
okay? So this is, thank you very much. No, I've forgotten. I'm ashamed to say, I've forgotten these things. I don't even. I think grade 12 is when I did it. No, maybe first year or something like that. So to say var complex, and the interesting thing here is when you have something like var complex, you can get there we go, var complex dot trio, boom, var complex dot image. Oh wow. Anyway, so I guess this is one way of experimenting with this, right? By default, your Python allows you to specify your complex numbers you want to work with. But there are also, I'm pretty sure there I don't know if the math package has a way of help math. There's a way of complex. Yeah, nothing. I wish there was a way of. But anyways, I would I would encourage you to maybe find time and poke around this. We just discovered something. I rarely use this as an example, but this is good. That if you check even the type here, it's complex, is it? It's a complex number. I guess. Okay. Something else to do here is maybe I can do a help on complex to try and see if I'll be able to gain access to documentation about complex objects, right? They're telling you exactly how you can do this and the sort of functions that you have access to. They're not a lot. In fact, if you do a DIR here, you'll be able to. We'll talk about this. You have access to things like, I don't know what the conjugate does though. These does, you can ignore them for now. Usually you want to focus on things when you're looking up things using the DIR inbuilt function. You focus on things that don't have two underbars, right? So I'm looking at conjugate, image, and real. At least I know what image does. It allows you to extract the imaginary part or the complex number, as I've been able to infer this, right? Dot image. And then if I do dot real, I get the real part, right? So my complex number here is defined as 2 plus 4j, ideally. But I don't know what conjugate does. I don't know the math experts in the room. Don't know. What does it do? Conjugate. What does this mean? What is a conjugate of like this complex number? The only difference I can see is a minus sign here. What does that mean? Sorry? We can't hear you. I don't know who that is here, but they seem to be telling us something important.
It changes the sign of the complex part.
Oh, it changes the sign of the complex part. Okay, that makes sense here. I wonder if I say 3 minus 5j, and I'm going to say var complex 2 is equal to this. Var complex 2 is that. What is the type? The type is complex. What is the conjugate? I missed math. I used to like math myself, but conjugate. Beautiful. So it changes the sign of the complex part. Thank you very much. A wonderful question. I really appreciate you asking these questions. The thing about programming, if you're doing this for the first time, like seriously, because this is not going away until you're done with this, right? So 2 years you'll be doing this. There's more programming coming, is it? The thing that is going to help you get up to grasp with things we're doing here, and the other course really where you're looking at programming is you're testing things out, you're practicing, right? So hands-on. Reading won't help actually. I promise you, right? It's not going to help you in any way. But actually testing these things out. So you fire up your Google Colab and then you're pasting things and changing them. If you notice, I was just changing things here, right? Just to test them out, you know? Anyhow, So that's that about numbers. At a later stage, we may use a math package as a way to talk about modules. So if you're working on math-centric things, you can use what's called you can import the math package, right? So you'll be able to do things like get cosine of specific numbers, the log. I don't know what some of these things are here. The remainder, the sine, signage, square root. The tangent. I guess hypotenuse and all those things, right? So you can use a math package. But also there are other more complex kind of libraries that will allow you to perform really interesting mathematical operations. They're complex things that probably people that have done math for a living in school, spent 4 years doing maths, will only be able to understand. I guess, or something like that. Okay, so that's numbers, right? And you want to remember these things because they'll pop up. The interesting thing about programming is that when you're constructing your program, you actually be using these basic concepts, right, to build more complex things. It's much like, in fact, it's more or less like you'll be building a house, and you know that when you're building a house, you need bricks, right? You need cement, you need windows, you need a ceiling board or something like that, right? So for you to come up with a program that makes a whole lot of sense here, you stitch together a lot of different things. But anyways, next up, strings, right? Strings allow you to define values, right? That will represent textual content. Okay? Now, the thing to appreciate here is that you define a string, or rather a variable, or rather a string value using single or double quotes. Okay, so for instance, if I wanted to just print out the word CSC space 6741, if I just write it like this, Python will tell me this is an error, sir. It's a syntax error. It doesn't know what this is. However, when I wrap it in double quotes, open quote, CSC 6741, closing quote, it's going to echo back this string like that. Also, if I use single quotes, right, opening single quote, CSC 6741, closing single quote, it will echo out CSC 6741. If I do something silly, like I start with double quote and then I close with single quote, it will tell me this is an error. Okay? It will tell me this is an error. And something interesting about quotes when you're working with text, right? Sometimes you'd want to quote somebody. Lighton said Python is good, right? And you want to quote, Lighton said Python is easy, not good. Now, you notice if I want to specify that this is a quote from what Lighton said, I would have to make sure that the things that I'm using to specify the quoted string here, the way I'm representing the quoted text here is different from how I've defined the actual string here. So that when I print this out here, it's going to echo out this like this, right? If that makes sense. Also, you notice here what I'm showcasing is I'm interacting with the interpreter to just tell it, print back this text, print back this text. In an ideal case, you just say, you create a variable var about Python or something like that. And then I would say is equal to this piece of text, this quotation. And then what you'd be doing is, you could check the type here, but what you'll be doing with this text is you'll be using it in so many different places. Again, the type built-in function returns str, short form for string, right? For a variable that is defined to hold a value that is a string, right? If that makes sense. Okay? What can we do with strings? We can concatenate strings, right? So join them together. We join strings together by using the plus sign, the same sign we use to add two numbers, right? Two ints, two floats, an int and a float and an int. Okay? And what happens when you use a plus sign is you're joining them. So for instance, it's a first name, first name, var, first name is equal to, I'm going to call this item, and then var last name is equal to period or something like that. What I can do here is I can say I want to join first name and last name. I have to concatenate them. Now you notice here, it's combining them without a space here because I've defined this like that. If I wanted to create a space, I can again concatenate an actual space, is it? Open quote, space, closing quote. So I'll just bring up the same thing. var first name plus space plus last name. There we go. Lighton space period or something like that. It's really quite common. I mean, imagine you're processing information that's going to render the grade for this student is that. But the names of the students are defined in separate variables where the last name and the first name is separate. You concatenate them. Okay? Or you could have something like var course. You're telling somebody, specify the courses you are enrolled into, right? Let's say, well, I'm enrolled into this. What is your name, right? var first name, Lighton period. You could say var first plus space plus where's the plus sign? Plus var last name, and then I'll say plus is enrolled in plus var course. Some crazy thing like this, right? So you're just stitching things together. Key thing here is you stitch text together, you concatenate or combine them using the plus sign on your keyboard. What else? We can repeat text, right? I can't really think of an example where you'll be repeating text, but you repeat text multiple times by using the asterisk, the same thing you use to multiply. Like for instance, I don't know, maybe on punishment, and you say, write, I love Unza, right? Write it 100 times, right? I love Unza, or something like that. It's crazy, I know. I can't really think of like a use case where you'd want to do this, but there you go, right? So you're just repeating text multiple times like this, okay? With an asterisk and the number of times you want to repeat the text, is it? There's something else that is interesting in terms of strings. The fact that you can, because a string is made up of characters, is it? Yes? I want to say it could be alphabetical letters and numbers. Like for instance, var course is equal to CSC 6741. It's made up of individual characters. What are these characters? There's a C, there's an S, there's a C, there's a space, there's a 6, there's a 7, there's a 4, there's a 1. So what we're saying is that there are ways of accessing, right, these characters. You use what's called indexing, okay? And it's as easy as specifying the variable that holds the string, square, open square bracket, close square bracket. Inside the square bracket, you include the index, right? The position of the character you're interested in. Positions begin at 0, right? And they end all the way up to total number of characters minus 1. So we have 0, 1. I'm just going to do this, colleagues. Indexing begins at 0. Wow. Indexing begins at 0. So if you have something like this, we're saying C is going to be equal to 0. S is equal to S. C is equal to, 1. C is equal to 2. Space. How can you say space here? Okay, space, which is nothing, is equal to 3. 6. 6 is 4. 7 is 5. 4 is 6. 1 is 7. We have 1, 2, 3, 4, 5, 6, 7, 8 characters in here. So the first index is always 0. The last one is going to be equal to the length of the string minus 1, which is 7. So what are we saying here? If we come here and we say, give me the character which is at index 0, it would be C. Give me the character which is at index 7, is going to be 1. Give me what is at index 10. Error, right? It doesn't exist because the total number of characters are 8. So the maximum index I can use to extract characters is 8 minus 1, which is 7. Okay, there's some nifty way of accessing the last index. You use minus 1, right? It's like going backwards ideally. So it would be like, if you want the last index, you can get the length of the string minus 1, or you can just say minus 1. It will give you the last index. Pretty straightforward and intuitive. There are instances where this becomes useful. We shall see this very, very soon, I guess. Like when you're extracting data, we want to manipulate data in a certain way. Say, I want to use the separator which is at index 5 or something like that. In fact, think about these relative to you want to think about these relative to these. If you've worked with Excel, there's things like left, right? If you've used these things, left and all those things, or index, right? It's the same thing, ideally. Anyways, hope this is making sense. Now, I've deferred our discussion of methods, right? Because it's a class, is it? var course type. This is part of the string class, and it turns out that this gives you access to a lot of methods, right? Like I can say I want to convert this course here, which is uppercase, to lower, right? These are called they are methods associated with the what do you call this? With the string class, ideally, right? So we're going to discuss this once we look at functions. For now, we're just interested in appreciating how we define strings, right? What basic things we can do, like we can join strings, concatenate them, we can repeat them, right? We can extract characters that make up the string. Very, very soon you'll notice that we can use built-in functions like len to find out what is the length of this course. Oh, it's 8. Okay, if it's 8, if I can use the built-in function len, that tells me the length of the string, then what I can do to extract the last one, if I don't want to use minus 1, is I can say var course. In here, I'll say len course, right? Something like this, var course, I guess. Var course minus 1, right? I'll get 1, if that makes sense. Don't worry about this. This will make sense when we look at functions. We'll talk about built-in functions and also look at methods, right, specific to classes. Very, very useful and powerful, especially when you start looking at modules, right? They say, I want to use Python pandas, accessing specific methods, right? Using a dot operator or something. I don't know if you remember me doing this when we were testing Python pandas, right? I was using pd.read, right? It's a function, is it? Read is CSV. It's a function. So it's similar to var underscore, which is a string, dot. These are the different functions I can use. Lower, find, strip, split. Split is wonderful. I use it a lot. Split, I'll talk about this though. Split on a space, right? It splits. Because CSC space, right? Splits. Or split on, I don't know if you can split on a 7 or something like that. Yeah, I don't know. Okay. So that's strings, pretty intuitive here. The other primitive type are booleans, right? Now, Boolean values represent truth values. There are two types of truth values, true or false, right? And it turns out that this true or false really, can be used in so many interesting ways, right? You will see them when you start looking at, I guess, conditional operators, for instance. You can test, right? You can test things here. Like you want to test, is the score is 49, right? Is 49 greater than 50, in which case it's a pass. False, right? If that makes sense. Right? So they represent truth values, right? In other words, they represent the values true and false in Python. If you were paying attention last time, I had mentioned that true and false are reserved words, right? Import keyword, and then when you go to keyword.kwlist, one of these is true, one of these is false. It's a keyword. Okay? Crucial to Boolean values are comparison operators. Like for instance, we can check if two values are equal to each other. We can check if two values are not equal to each other. We can check if one value is less than the other value, if one value is greater than the other value, if one value is less than or equal to the other value, if one value is greater or equal to the other value. And these are the operators we use. So for equality, it's double equal signs. Okay? Is a pass mark is equal to 50? Is the pass mark truly equal to 50 for postgrad? True. Is it equal to 45? False. Right? I'm checking for equality using two equal signs. Notice there's a difference, right? One equal sign, this is an assignment operator, right? You're telling Python, hold this value 50 in this variable. In this particular case, you're telling Python, check if the value held in here is the same as this value on the right. Okay? Easy enough. The tricky thing here is when you're checking if two values are not equal to each other, the not equal is exclamation mark followed by equal sign. Right? So if I say var pass mark not equal to 50, this is false, is it? Because we know that to the left here is 50. So if we can't say 50 is not equal to 50. This is false because 50 is equal to 50, right? But we can say something like 45 is not equal to 50. This is true, right? If that makes sense. Okay? So the tricky thing here is usually it's the equality, right? And the not equal to operators. They'll be confusing when you start off for the first time because they're unlike what you do in mathematics, right? Or like normally in real life, ideally. The others are the same, right? Less than symbol is the same, right? It's like, is 45 less than 50? True. Is 45 greater than 50? No, it's not, right? So it is. Is 45 greater or equal to 50? False. Is 45 less or equal to 50? True, right? Is 50 less or equal to 50? True. Is 50 greater or equal to 50? True. If this makes sense, right? The thing that you want to do here is pay particular attention to equality, two equal signs, and not equal to, right? Negation, I guess, which is exclamation mark followed by the equal sign. The key thing here is when you have an operator, one of these operators, acting on two Boolean values, the result is always a Boolean value. Now, it raises interesting things here, right? It's like, well, if true is a Boolean value, what happens if we say true is not equal to is not equal to false. We know that this is true, right? Because true is not equal to false, is it? But if we say true is not equal to true, we'll get false, is it? Because we know that true is equal to true or something like that. I'm just playing around with the actual Boolean values, true and false, to showcase, to say every time we have an operator operating on Boolean values, we get back a Boolean value. Okay? I guess, I don't know. Now, there's also, I don't know if I have examples here. Wow. There are also logical operators. I don't know if you remember these from grade 2, right? Or and not, is it? Right? I don't know if you remember this from grade, I think it's grade 1 now. But you guys, you know, I went to school in grade 1 a long time ago myself, but we didn't do this. But I think you guys, most of you probably did this in grade 1 or grade 2, right? Logical operators. There are 3 of them, right? And, or, and not, right? So it's like, one of them is an unary operator, right? Not. Not is like negation, right? you use not here to check. I mean to get the opposite of of another value, if you will, right? Anyways, and then and or are binary operators, right? They require that they operate on the operations themselves operate on 2 operators, right? And is an operation. The operators are the things you're playing around with. Okay? I don't know if this is making sense here. So the idea here between the idea here when you're talking about logical operators is that there are instances where you may want to combine, and you see this in action. You may want to combine results, Boolean operations. For instance, for you to proceed to part 2, you must pass CSC 5019 and CSC 6741 and all those 8 courses. So it's and, right? Right? For you to proceed to next term, you must, I think you must pass at least one of these courses. So is this a pass, or is this a pass, or is this a pass? If this is making sense here. Anyways, maybe a few examples here may help here, but the people that have done maths here, also I know at first year, if you did computing, for some of you, they'll tell you that they'll tell you about, I don't know which one is conjunction, I think it's and or something, you know, and is conjunction and then disjunction is or, right? So the idea is simple here. With and, you're going to return true only if both operators are true, both values are true. Whereas with this disjunction, they told you that you only return true if at least one of them is true. Is it? So what do they say? For conjunction, which is and, we are saying true and true will give us true. Right? True and false will give us false. False and true will give us false. False and false will give us false. Right? Because with conjunction, you only return true when both of these values are true. Okay? Whereas with disjunction or, if either one of the values is true, you return true. So true or true is true. True or false is true. False or true is true. False or false is going to be false here because false. It's going to be false here. Right? So you can derive what's called a truth table if you want to play around with this really. And again, you notice when you start looking at conditional statements that this will make sense here. And I'm trying to see here. I want to give an example of like a classic example of where you'd use disjunction or I don't want the thing I used here before. I don't know if what I have here works here, probably not. I'm trying to think of a nice use case here where you would use both conjunction and disjunction or something. We know that for you to pass, one of the conditions is var CA must be a pass, right? CA must be a pass, and var exam must be a pass. So in other words, what we can do here is we get a score here. var CA is equal to, let's say 45, it's horrible here. var exam is equal to 60. Now if you get the average, right? var CA plus we can var exam here, we can experiment with some of the things that we've done before here. Divided by 2, get the average here. The average is a pass, but technically speaking, if we follow the rules of the UNZA, this is a fail, right? So we would say if var CA, right, is greater or equal to 50 and var exam is greater or equal to 50, then we say this is a pass. Print pass. And this won't print anything here. Okay, maybe I should. If this is this, else print fail. So this is going to print fail, is it? Because the CA is not greater than 50, it's less than 50. It's a classic example where we are using conjunction, right? And both conditions must be true for you to get the result that you want, right? There are instances where you need you need or here or something like that. I don't know. I'm trying to see, but I can't use this same example here. I don't know, but I'm sure I can think of other examples. I wanted to think of an example where you are, where you are using this. But anyway, I'll try and see if I can dump it in the. Maybe people can think of an example. I don't know. I can dump it. So in other words, for the what do you call this? Conjunction and disjunction and or here. Assuming you have two values A and B. What we know is that there are four possible scenarios here, is it? Either A is true and B is true, that's one, or A is true but B is false, right? Or A is false and B is true, or both A and B are false, right? So when you are performing our operations, we're saying A and B, A or B, it's called a truth table, right? True and true, true. We can true or true, true. True and false, well, false. True or false, true, right? False and true. Oh, false. False or true? Oh, true. False and false. Well, false. False or false? False, I guess. So it's called the truth table. I don't know. It will make sense once you start looking at conditions. Okay? Disjunction, conjunction. I don't know if I butchered them, but disjunction, conjunction. I used to teach, logic gates at first year, all back here. But, things have changed now. Right? I haven't taught it in the last 2 years, but I still remember some of these things here. Is this how a computer works, is it? They say all a computer does is it works with numbers, right? Ones and zeros or something. It turns out, like, at a very low level, you're working with gates that will either be true or false. There are a lot of them, billions of them, right? Transistors, really. And what happens inside is, like, a 1 or a true is typically a high voltage, and the false is a low voltage. So, and it turns out that using these things here, you can add numbers, you can subtract numbers. It's interesting. You can divide. With addition you can add, right? You can represent multiplication rather with addition and subtraction and stuff like that. But anyways, what else? Negation, right? Remember I said negation not is an unary operator, right? So if it's an unary operator, you only have one value, right? Input, it's 2, right? True or false. And then when you have not here, not A, it's like not true is false and not false is true, ideally, right? So much so that not true is going to be false and not false is going to be true. You can't have either one of the two or something like that. I hope this is making sense, right? We want to get up to speed with Boolean operators. In terms of how this type is represented, if you check the type using the type built-in function, you'll notice that it's BOOL, is it? Boo, right? Short for Boolean value. Okay, and what I have here is just an example where I'm using these comparison operators. I have age defined as 20, right? Here, print var underbar age greater or equal to 18. Is 20 greater or equal to 18? Of course, it's true. Is 20 equal to 21? False, because 20 is not equal to 21, right? And then I define a variable here equal to true. Not true is going to be false. If it was false, not false is true, ideally, if that makes sense. All right, and then I have like I'm combining different operators here using and or, right? It's like var age, which is 20. 20 is greater than 18. This is interesting. A nice way of getting started with these things is you want to work them out at a very basic level, right? You say, well, I have age, I guess. Defined as, sorry about that, I lost my connection with my other thing here. I have age defined as var is equal to 20 here, right? Like so. Ooh. Just going to go down here so that people don't get confused. Like this, right? It's like when you say print var age, and I also have permission defined as true. It's like what I'm saying here is I want to print, I can break this down, right? I want to print 20 is greater or equal to 18 and permission is true. But I know that 20 is greater than 18 is true. Okay? So, and I also know that true and true is true. So the answer is true here. Is it? Here. True. Well, what about this one? I know that age is defined as, I'm going to copy it again here, so I don't pollute what is here. I know that age is 20, so I want to print 20 is greater or equal to 18. Okay, 20 is greater or equal to 18, or var permission is true. Okay, that's fine. 20 is greater than 18. This is true. True or true is true. No, I've defined, this has been, yeah, it's true. So it's true, right? If this is making sense. This will pop up when you look at conditional statements. Are there any thoughts or questions so far? Okay. Okay, that's fine. Hopefully Boolean operators make sense here. Now, there are instances where you may want to convert one type to the other, right? It's called typecasting in some languages. And the classic example here you will see is when I'm giving an example here, when you're getting user input, so you're defining a variable, first a variable score, and then you say this is going to be equal to input, enter your grade. So this simple code here is asking a user to enter their grade, right? And then the user enters their grade. So my grade is 45 or something, and then you have a kind of like a program that checks if it's a pass or a fail. So you're going to have something like if var score is greater than or equal to 50, then print pass. Else print fail. Now here's the thing. This will fail because the way the input, to talk about the input function later on when we look at functions, the way this works is it converts this into a string. So var score here is a string. If I check the type here, it's a string. And because it's a string, right? It's like I want to compare a string against a number, against an integer here, which won't work. So what I have got to do is I have got to convert or cast it. So in other words, I'm going to come here and say, I'm going to define this, but I will cast it using the int built-in function. I want to convert this to an integer. Boom. Enter your grade, 45. And then when I come back here and I say if this is less than that, print pass, else print fail or something like that. This will print fail. It will work. So it's called casting. Now the key thing here is that there are built-in functions, right? Python has built-in functions that allow you to convert one type to the other. Like for instance, I can convert the number 50 into a float using float function here. So instead of 50, it will be 50.0. Or I can convert a float to an integer, right? So instead of, if I have 50 here, I'll get 50. 50.0, I'll get 50, like this. Or if I have a number, a string, if I have a string 50, and I want to convert this into an integer, I'll do this int, right? So that this string will be converted into a number. Very, very useful, like that. Okay? So there are built-in functions to do conversions here. You know, you can convert to string. I want the number 50. 50 here is an int. But I want 50 here to be converted into a string, str 50. This will be a string now, right? So I use str built-in function to convert numbers like 50 into a string, or 50.0 into a string. You notice that if I convert a number like an integer into a string, the number itself is quoted, right? These single quotes. The floating point here is quoted. Okay? Hope this is making sense, I guess. I don't know. And I just have a series of examples where I'm doing typecasting. I'm using the built-in function to just check these things here. It's pretty straightforward stuff. Okay. What is also interesting here is when you're dealing with Boolean values, like certain types of numbers, the number 0 is considered false, is it? It becomes useful, by the way. So if I say boo 0, it tells me this is false. Boo 1 is true. Okay? An empty string is false. A non-empty string, false. A non-empty string is true. Non-empty string is true. Okay? But an empty string is something that, well, there's no value, right? So open quote, close quote. If I have open quote, space, close quote, this is not an empty string because you have a space there. So this will be true. But without a space, false. I don't know if this is making sense, everybody. All right. So for numbers, a 0 is false. Any non-zero number is true. So boo 1, boo 100, these are all true. Boo -1, true. Anything other than 0 for numbers is true. The 0 is false. Are there any thoughts or questions so far? I guess it's making sense. Okay. It's neither here nor there. I guess people already understand what this is all about. All right. So now that we understand the basic primitive types in Python, Boolean, numbers, strings, it turns out that when you're writing computer programs, many a times you find yourself writing conditional statements. The conditional statements will help you make decisions. I've kind of like already given a hint on use case where you'd want to make decisions, right? Like for instance, you're writing a simple program that tells you whether a score is a pass or a fail. You have two outcomes, is it? A case where the score is a pass and a case where the score is a fail, right? So you use a condition. Now a condition is nothing more than an expression that we evaluate to true or false. Is this number less than 50? Right? It's either true or false, right? And it turns out that it will run a block of code only if the condition is true, ideally. Right? So if I associate the condition to a block of code, that block of code will only run if true. If you have two conditions, the if has a pair which is referred to as an else, right? In instances where you would want to run two pieces of code, you'd say if the condition is true, run what is part of the if block. If the condition is false, run what is part of the else block. Okay? There are, however, instances where you have multiple conditions, right? Like observe. You use elif. Observe. The same example, right? Checking if var score is pass or fail. You only need if var score is less than or is greater or equal to 50, print pass. Else print fail. This is simple enough. Now imagine the same score, right? Checking if var score is A is A plus, A, B plus, B, C plus, C, D plus, D, or outright fail. You notice the difference here. You can't just use if and else, right? What you'd have to do here is you construct an if, elif, elif, and until you get to else, right? So we are saying here that when you're making decisions, you can either use an if with a paired else. In fact, you can use a lone if here. It's like if score is greater than 50, pass. If it's not greater than 50, then you won't get anything. It will be blank like that. It works. Right? Like var score, observe. var score is 45, right? If I just say if var score is greater than 50 or equal to 50, print pass. This will run, but it won't print anything because var score is what? It's not greater than 50. But if I write, if var score less or equal to 50, print fail. This will actually print fail, right? Fail, like that. If that makes sense, right? So you notice here, I have like an example here, right? Where you are using these sort of conditions here. Like, if it is raining, take an umbrella. Otherwise, just leave without an umbrella. Don't bother to get an umbrella. Weird, but hope it helps put the point across. Okay, and then so I have examples here. I mean, I've kind of like already used some examples here, but I'm going to walk us through this anyway. We are defining a variable called var _ temperature with a value 30, and then we are saying if the temperature is greater than 25, we're saying it's hot, right? Else if, the short form in Python for else if is elif. Elif is else if, right? It's unlike other programming languages where you literally have an else if here. So elif var _ temperature greater than 15, right? It's warm. Else it's cool. So it's like you have three conditions in this particular case. If the temperature is greater than 25, it's too hot. If it's greater than 15, it's warm. Otherwise, I don't know if you're getting the point here. If, you know, we're going to say if this, I'm going to remove these comments here because they're distracting. What you're saying here is, if you pay particular attention to what's happening here, given a temperature, it's like you're saying, you're going to check if the temperature is greater, if it's more than 25, so anything above 25, 26, 27, 30, 40, 50, 100 degrees, it's too hot. Else, if, now this else if implies that if however the temperature is anything between, it's greater than 15, meaning that it's between 24 and 16, you're going to say this thing is warm. So if you're punching in numbers, this is what this means, right? You're first of all checking if it's greater than 25, and then afterwards you're checking if it's greater than 15, but implicitly you're saying, because if this condition fails, it comes here. In this condition, we only fail for numbers that are below 25 and below, actually. Is it? So it's beginning 25. Or 25 won't be checked, actually. It won't be checked. So it's beginning 24. Okay? And so it's going to be 24 to 16. But if it's anything less than this, It's like if you type in 14 or 0 or 1, it's going to be, it's cool. And you can test this also, right? So, say we can define these and check them out. Let's check a temperature. Let's check a temperature value that is above 25, let's say 100. We expect this thing to print out, it's too hot. But why is this not, is it indentation or something? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Sorry about that. Indentation, colleagues. Indentation. In copy paste, I was all usually confusing like that. So this is going to be, it's too hot. If we look, and this is beautiful actually. If we type 25, which is in between here, let's see what happens. And you want to be careful about this, right? It's warm, right? So it includes 25, I guess. Yeah, it includes 25 because you're just checking for anything that is greater than 25. 25 is not greater than 25, so it will be, it's warm. So it starts with 25 like this, right? Yeah. So anything that is between 16 and 25 is going to be, it's warm. So if again I check 17, it's going to print it's warm, right? If however I print 15, it's cool, right? Because 15 is not greater than 15, is it? So we're getting 15 and lower. If I print negative 10, it's going to be, it's cool. Now, this raises interesting questions, right? Like when you're defining these conditions, like if you wanted to check the, and I'm going to leave you to do this as homework actually. If let's say you want to implement this, this, I remember we discussed this, but I'm going to show you what I mean here. Wow. If we want to implement this, you want to think about this, right? It's like, how are you going to do this? Well, it turns out that you either start with the lowest threshold, you start going up, or you start with the highest, right? You're checking conditions. If a value falls within 86 and 100, then A plus. Elif 75 and 85, A. Elif 70, 74, B plus. Elif 65, 69, B. Elif 55, 64, C plus. Elif 50, 54, C. Else, D. Right? And yeah, but you want to be careful here, right? With using else here, because it would be like if somebody types in negative 10, it would be D, but it should give an error or something like that. So you want to make sure that you are restricting, because the normal grade is only going to be 0 to 100, if that makes sense. Do you understand this? So just try this out and see, as a way of experimenting with this, try and see if you can write a simple program. Try this out, please, before we meet on Sunday. You try and see if you can write a simple program that will print, given a score, it will tell you whether that score is an A plus, an A, a B plus, B, C plus, C, or a D, using this specification here. And what you're doing is you're using these ranges here. Right? These ranges, I was going to say, can you then use, this would be interesting, right? So you write a program that uses the score ranges to specify whether a grade is an A plus, A, B plus, B, C plus, C, or D, and then write another program that will tell you, using the grade here, it will tell you whether it's a distinction, merit, credit, meritorious, credit, pass, or fail. Now you notice here is, it will be like, in this particular case, you're writing a program that's going to ask somebody, enter if your grade is, enter the grade you got. So if somebody enters A plus, to tell them distinction. if it's an A, distinction. If it's a B plus, meritorious. If it's a B, credit. If it's a C plus, credit. If it's a C, pass. So you notice here that you need to use O's, is it, for the grade. If grade if grade is equal to A plus, or grade is equal to A, print distinction. And if grade is equal to B plus, meritorious. And if grade is equal to B, or grade is equal to C plus, credit. And if grade is equal to C, pass. Else, fail. Or if you want, you can have and if grade is equal to D, fail. You want to try out these two? You try them out at your own time as homework. I'm glad I thought about this. So you're going to see, you're going to implement two. Yeah, this is just for you to, it's not really like zombie grade or something, but this is for you to kind of figure things out here, right? So you're going to write a condition or code that prints grade given a score, and then write code that prints classification given grade. So these two. Okay. I don't know if this is making sense here. Now, what you begin to notice is that when you start defining these conditions, right? In fact, I showcased the error here. Indentation matters, is it? The code block after the if, elif, and else must be indented. Can be using a tab or 2 spaces, but usually it's 4 spaces. And so what the interpreter, Python interpreter does is it will use the indentation to know which statements belong to this condition. So in this particular example here, everything that is indented after this if block is tied to this first if block. So if I had another thing here, pass or print yay or something like that, this would be printed yay, right? We can have this print really cold, really cold, right? So you notice here, if I run this, it will print it's cool followed by really cold in the next line, right? It's cool followed by really cold. Wrong spelling for cold here. Why? Because these two statements here, print it's cool and print really cold without a D here, are tied to this else block. I'll just say ish. I need water or something. So that if I punch in 100 here, I'll first of all print it's hot followed by ish, I need water, right? And stuff like that. Good stuff. So I start up making decisions. Some examples, pretty straightforward stuff, right? We have a variable var underbar age, which is equal to 20, and var underbar has permissions, same as before. And then we have this if statement. If var age is greater than or equal to 18 and var has permission, then access granted. Okay? So in other words, we only grant access if both of these are true. And in this particular case, it will be true because var underbar age is 20. 20 is greater than or equal to 18 is true. And then var underbar permission is true. So it's true and true, it's true. So if true, then access granted. Right? Another thing here is if var age is less than 12 or var age is greater than 60, you get a discount. In the Republic of Zambia, places like Builders Warehouse, I was working with my dad, they offer discounts to those that are above 65. I don't know about those that are younger, right? So it's like you're saying, in this particular case, you give a discount if either one of these things are true. And in this particular case, it won't, right? Because 20 is not less than 12, it's false. I'm going to do this here. But why? Look at this. We have two variables. We'll come back here down. We have two variables, this, and then the first condition here. If what we're saying here is that 1, 2, 3, 4. This condition here is going to print access granted. If you run this code here, it will print access granted. Why? Because var age is going to be replaced by 20. So it's like you are going to get this. I'm going to repeat it here. 20 greater than 18. This is how the interpreter is going to do it, right? So 20 greater than 18 is true. How about var permission? Oh, var permission is true here. And then we have this. We're checking true and true. If you remember the truth table, right? True and true is true, right? This. True and true is true here, right? So if true and true is true, then if true, this only executes if this expression is true, if that makes sense. Well, what about this? Using these same variables here. I'm going to go all the way down here so that you're not confused here. So it's like you're saying, you're going to get this, and then you say var age is 20. Right? You're going to get this, we evaluate it again. So you're checking, is 20 less than 12? No, it's not. This is false. Well, is 20 greater than 65? No, it's false. False or false is false, right? So this won't be printed. Nothing will be printed if we run this code here. Nothing will be printed. Right? Nothing. But if we look at somebody who is 70 years old or something like that, like who is above 70 years, my dad or something, and I render this here, it's going to print, you get a discount, right? Why? Because the condition that is here, this we evaluate to true, even though this is false. So it's false or true. False or true is true. So all I'm doing really is I'm going here. I'm in my mind, I'm using the truth table, right? False or true. Or, right? This is or. False or true is true. Do you understand? If I come here and I say, well, I want to see if a 10-year-old will get a discount, this is going to be printed. Why? Because 10 is less than 12. So this expression to the left is true. Or 10 is not greater than 65. It's a false. So it will be true or false, which is true. So it's going to print this as you get a discount. All you have to do is remember that you have, for those Boolean operators and or, you have two values, right? Two operators. True and true is true. True and false is false. False and true is false. False and false is false. And then true or true is true. True or false is true. False or true is true. False or false is false. Right? That's it. This truth table here is the key to conditions. And conditions can get kind of complex, where you can have actually maybe even 3 conditions or 4 conditions. What you do is you kind of like perform them in succession, right? So for instance, if you had a condition here where you wanted to check also if age, I don't know when here, but and, right? And age is or age is equal to is a special case here. You've just turned 18 or something like that. 18. So we want to give a discount to people that are less than 12, to those that are greater than 65, and those who have just turned 18. Right? So it's like all you're doing here is you're checking, right? This is going to be you get a discount, right? If we change this to 17, it won't print anything, right? However, if we change this to 18, it's going to print, you get a discount. Why is this printing, you get a discount? Well, it's almost like, I've polluted this also. It's almost like you're saying, you're going to be checking VAT, this is 18, right? It's 18. Is 18 less than 12? VAR age here, 18 greater than 65? And for you to understand this, I'll wrap them in parentheses so that this is a lot clearer than it is right now. Or 18 is equal to 18, right? So you're going to come here, it's like the interpreter is kind of like evaluating this like so, and then you're checking 18, is 18 less than 12? Well, this is false, because 18 is not less than 12. Is 18 greater than 65? False, right? Is 18 equal to 18? This is true. Now you see, the logical operators under or binary operators, they require two values. So what you're doing here is you're doing this left, right. So you're going to come here and you're asking yourself, false or false, right? False or false? Well, false or false is false, obviously, right? This is false. And then you're then going to ask yourself, false or true? False or true is true. You know, so it's not like the operation is done like in one step, right? Because this is a binary operator, I guess, if that makes sense. I don't know. I don't know if this is making sense. I'm going to pause here for comments in terms of...
Yes, it's making sense.
Okay. Unless with any questions, we're going to proceed to loops now, right? Loops. It turns out that when you're writing programs, there are instances where you may want to do the same thing over and over again, right? You're looping, you're iterating, you're cycling through. These are called loops. I'll give you an example. When you start looking at pandas, for instance, you have records for 22 students. I don't know how many people are logged onto the class here. I have 25 minus me, I guess, and my presentation here says it's 23. So you have 23 students, and what you want to do is you want to loop through. You have a program here that is going to loop through to print all the students' first names that are currently logged on to this class, right? So it's like all you're doing is for each student print first name. You're looping, you're doing the same thing, it's the same operation, but multiple times because the operation is acting on different input, ideally. You see this actually when we start processing data, like if you're using pandas, for instance, you loop a lot, right? I can show you right now, I guess, if you remember last time here. Let me see if I can find this thing here and do a source on VNV and activate this, and then I'm going to go in Playground because this is where I have my, is it this data, something like so Python, import pandas as PD, and then I'll do var unser dspace is equal to pd.read csv. This and then sep is equal to, I think it's pipe simple or something. So var unser this. It's like this, right? I have how many? What's the shape? I don't know if we have done this already. Maybe not here. But I have. We'll look at this later on there. But I have these records, right? And in this I have title, right? Right. So I'm saying I have var unser title. Now I know this because this is iterable, right? So I'm saying for each of these records, how many are they? 1,833. What I want to do is I want to print the title. So I'll say var title in here. Print the title is followed by, this is a string also. The title is followed by var title or something like this. So what I'm doing here is I'm looping, right? I've done this 1,333 times. For each title, I'm just printing the title is, but you can kind of think about this operation here as it could be anything really, right? You could be modifying this, like you want to modify it in such a way that each title is lowercase, right? I don't know. But anyways, so looping is quite important, right? And we're going to start off with a for loop. The two main ways of looping, using a for loop or a while loop, okay? So with a for loop, you iterate over a sequence, okay? Typically, it's you loop through a predefined sequence. You already know how many times you're going to loop. You use a for loop. That's the one distinguishing factor between a for loop and a while loop is that with a for loop, you know how many times you're going to be looping, but with a while loop, you don't know, okay? So you notice here that you loop over a sequence, and incidentally, something that's iterable. I am looping through this. What is var? I'm looping through this here, if you notice. This. But what is this? This is a series. It's a Panda series here. Right? It's iterable. But you can loop through sequences like a string, right? This is what we're saying here. You can loop through a string or a range of numbers, or a list, or a tuple, or a set, or a dictionary. As long as it's something that you can iterate through here. It's a sequence, ideally. Observe, course, which was here, var course. Remember var course? Well, for var character, I'll call it C in var course, print the character. So I'm going to print on a new line each of these characters, including the space. C, S, C, space, 6741, right? I'm looping because a string is a sequence of characters, ideally. Okay? Okay, so the syntax is simple, right? You start with the for reserved word or keyword, followed by a variable that is going to hold the things you are iterating over. So this is defined by yourself, followed by the in reserved word, followed by the variable representing the sequence, or it could be the sequence itself. Now you notice there are two keywords that we're using here. Again, I'm going to draw attention here to keyword.kwlist, right? The word for is a reserved word. The word in is a reserved word. Okay? So it's for followed by a user-defined variable that is going to be used to hold the things you're iterating in space the sequence, which can be a variable. So in essence, what happens with a for loop is on each iteration n times, the variable var underbar item in this particular case will hold the next value from the sequence. And then you can do your manipulation however you want to use it. Now, I have an example here, really weird here. I have fruits, apples, bananas, and cherry. And what am I saying here? Following this syntax, for followed by any variable that you want to use to hold the next item to iterate through, followed by in, and then the variable holding the list in this particular case. Full colon, and then what follows in the body, what is part of the for loop body here is what is done, right? In this particular case, we are printing the fruit. Okay? If that makes sense. So again, if we just copy this, I guess, list is iterable. Remember, we don't need everything after the pound here. So we're defining a sequence which is holding fruits, is it? This is a list. A list is iterable, right? List. It's a list. It's a list, and then I say for followed by a variable that you can define yourself. This can be I, A, B, any name that conforms to the what we defined as the rules, right, of defining variables. right? So in this particular case, I just want to say I, or I'm mentioning I here, and then followed by in what? Well, the sequence which is represented by this variable called var number fruits. Full colon, enter, 1, 2, 3, 4, body of the for loop. I want to print I like that. Apple, banana, cherry. There's something interesting here. This doesn't have to be a variable, right? I can have for j in, I want to have this list here. Apple, beans, banana, print j. It's going to work still because I'm iterating through this here. If if I lost connection, can you still see my screen? I can't see it on my other.
Yes, we can see your screen.
Oh, okay. I don't know what's happening with my phone, my mobile device here. Okay. So the key thing here is notice the things that are tied to the for loop have got to be indented, right? So that they appear, so that you explicitly tell the interpreter that this is part of the for loop body. Otherwise, nothing will happen, right? Nothing will happen. Or you get errors or something like that. Okay. I'm just showcasing output here. Now there are smarter ways of looping. Sometimes you can use again, we'll talk about the range here. Range is an inbuilt function. What range does is it kind of it prints, right, a series of numbers. If you feed it, I mean, you can overload it. There's different ways of using it, but the simplest way of using range is you feed it what's called a parameter, a number, right? Range, open parenthesis, number, close parenthesis. You will loop beginning 0 all the way up to the number minus 1. So in this particular case, what range returns actually is just an enumeration here, 0 through to 3 here, 0, 1, 2, 3, right? Well, you won't really see that 0, 1, 2, 3 here, but if I loop, so range returns 0 to 3, but this is telling you that this range has created an iterable object that will allow you to move from 0, 1, 2, 3. Observe, for I in range, full colon, print I. It's going to print 0, 1, 2, 3, right? 0, 1, 2, 3, right? So you are printing everything beginning 0, stepping one at a time, right? All the way up to 4 minus 1, which is 3. It's a nice way of looping here, right? You know, so generating a sequence of numbers. It's a nice way of looping here. And this is what I have here, right? What you can do is you can use an evolved way of range, a modified way or an overloaded way of an overloaded version of range. And again, I think I'll have to apologize that we're talking about built-in functions before we discuss functions, but you know, at some point you have to discuss some of these things even if you haven't yet, right? But this version of range uses the default step, right, which is 1. So it's like 0. If range 5, 0 plus 1, 1, 2, 3, 4, right? So you're stepping one time. However, when you have specified 3 values, like in this particular case, you can state when you want to start, when you want to stop, and the step, like how many times you want to move to the next value. So in this particular case, I'm saying I want to start from 2, I'll stop at 10 minus 1 or something like that, but I'll be stepping 2 times, so that I'll print 2 first and then plus 2, because I'm stepping 2 times, so it's 2, 4, plus 2 it's 6, plus 2 it's 8. If I do plus 2 it's 10, but I can't print 10, right? So I'll just print 2, 4, 6, 8. In other words, what I'm saying is when I want to loop through 2 to 10, step 2 times here, I can do it for j in range print j 2, 4, 6, 8. If that makes sense here. Don't know, right? I don't know if there are questions about looping. What's important is the syntax. For followed by the variable to hold the next value you're looping through in a sequence. A sequence can be a list, guys. can be a tuple, 2, 3, 4, 6. For x in var tuple, print x. I'll print 2, 3, 4, 5, 6, like that. I don't know. But this one is not working. Why? My internet access. Wow. Crazy stuff happening. I don't know if people can still hear me, but I hope you can. I don't know what's happening. Oh, there we go. Okay, so there's also a while loop, right? The thing with a for loop here, you notice that you're looping through a predefined number of times. You know how many times, right? With a while loop, you're going to be looping until, for as long as the condition is true. The moment the condition becomes false, you stop looping. Right? You stop looping. So imagine a situation where you're looking for, you have a list of students, right? There are this list of students right now, all of you logged on. I can say, I'm going to extract the names, which I can right now because I keep track of who's attending class here. I want to get a list of all the students, right? And then I'll say, it's this one which is still in progress. I'll get the list of all of these students, right? These. And I'll say, but I will stop the moment I find a student, right? Maybe we can use this as an example, don't know. But where is it now? It's gone. It's not working, I don't know why. I'll try it some other time. I wanted to, it's not properly formatted also. It's not nice, is it? Maybe I can use, look at this. It's horrible. Maybe I can use Google Sheets instead. Demonstrate this. Right, so I can say I want to create a list, right? And I'll try this. I'll try and demonstrate this, by the way, so that this hopefully kind of makes sense or something. I'll try and I'm trying to see if I can demonstrate how this works. You know, also this thing is not it's not showing me what oh, it's this one. I need to rejoin this. So I needed to rejoin just in case so I can say I want to loop through this thing again. I want to loop through the list of names of all students here, right? And I want to stop when I find Emmanuel or something like that. Right? We can do that. So it's different, is it, this time around? Because you don't know what you're looking for. There's a condition. There's a condition. There's something that you're doing that will enable the condition to be false, in which case you stop looping. Okay? The thing, though, is when you're using a while loop, because you're constantly going to be looping here, you want to be very careful that the condition will eventually converge to false, right? Otherwise, you go into an infinite loop. It's called an infinite loop, right? And you run out of compute resources, ideally, right? So the syntax then is you define a variable. Typically, this variable is what is going to is what you're going to use here to terminate the while loop, right? So if you look at this example, I'm saying variable count is equal to 0, right? I'm starting at 0, and then I'm saying I'm going to loop for as long as count is less than 5. Meaning that for me to stop looping here, I have got to change the variable count somehow. So in this particular case, I'm just saying every time I loop, I will just add 1 to count. And then eventually when I'm adding 1, initially it's 0. When I add 1 in the first loop, it will be 1. I loop, it will be 2. I loop, it will be 3. I loop, it will be 4. I loop, it will be 5, and then I can't do anything anymore because this condition will be false. Okay? If that makes sense. Right? So this would be like the result of this while loop. Now here's the thing, right? It's like if I wanted to use this as an example, it would be nice using an example here. I want to, I don't know if we'll be able to do this together. I think we can. I have hope in all of you. So we can say I'm going to split this by, I'm going to split this by, okay. Let's see, what can I just, I just want your names here. I'm just going to say, split this by this, right? And then I'm just going to say can I do a 0 here? No. Can I do, see now, Excel, I mean Google Sheets here, index 0. Beautiful. So I'm going to say it's not working. It's okay. I'm going to just say split. It's fine. Why am I? Yeah, splitting and index. I just wanted to return the first one, but it's okay. It's okay. I'm just going to. I'm just looking for first names anyway. So I just print formula here, and then what I want to do here is I'm going to say. Because I want this to be exactly the way they are, right? I will say trim, and then also I will say, after trim, I'll say lower, right? Beautiful. So I'll just say, I will print and print and print all the names. All of these names, I'll create a list here, text join. I'll do a text join, comma, is it? True, ignore this, and then do this. Get all of these things here. So what I want to do is I want to create a list of your names, right? So I'll just say var CSC 6741 students, and then I'll just say add them in a list like this. And this is wow, this is horrible because here I have to, these have got to be concatenated, concatenate. Woo. Okay, concatenate this and this and this. It's horrible like that. Concatenate like this. Formula, and then I'll get this. It was failing here because it's supposed to be text, right? So I'll say var CSC 6741 students is equal to this. This will work now. Not sure why this is failing, but I have a sneaking suspicion it's probably because, don't know, maybe because var CSC 6741 students is equal to this. Maybe it's because of John here, especially. No, I don't think so though. It's quoted here. This should work though. Don't know why it's failing. Wow. But I didn't forget any comma here. This is a comma, Torias. 1, 2. Don't know why this is fading. Let's see here. This is the thing about programming. Sometimes there we go. It's light ons. You see this stupid stuff. There's a thing that says light ons thing. Horrible stuff. This one. So this will work. I've just removed the light ons thing. Okay. So I have this, right? I have this iterable thing, and then what I want to do is I want to loop up until I find Kalenga or something like that, right? So what I can do here is I can just say var student is equal to Kalenga, right? And then I would say while var, and this is a bad example by the way, because we haven't discussed this important thing here, where you can break. You stop looping once you find what you're looking for. You break out, right? So I'll say var I'll just call this item here in var csc this, right? While this is not equal to Kalenga. While this is not equal to var student. Sorry, while var and this is going to be horrible here, because I'll still need to loop through this, sadly, right? I still need to loop through this. It's almost like I'll still need to figure out a way of so I'm just going to go while var student, right, is not equal to Kalenga or something. So if I say if the name of the student is not equal to Kalenga, right, I'm going to be printing these things. I'm going to be printing these things. I'm going to be printing these things. But the thing is, with this problem that we've created, we need a way of getting to the next item, right? Let's solve this. Actually, it would be nice if we solve this. We don't have to define variable. Well, we can, I guess. While var student is not equal to, in fact, what I should have done here is I should have signed this is equal to this space, right? And I said while var student, if the student is not equal to Kalenga, what am I going to do? I'm going to get into this loop, and then I'll print the var student. But there's something interesting about what's happening here. It's like we are looping through, it's a list, right? It's a list. And so we need a way of printing, of getting to the student name ideally. This is interesting here. So we're going to go to this and say, but you know, it's the thing here. I'll have to still loop through this using a for loop, which is not what I wanted here. I'll say var I in actually I don't necessarily have to loop through this here. It's like var student is equal to var student is equal to this. I still need the index. I still need the index. So what I'm going to do is I'm going to say var student is equal to that var index this is the thing when you don't plan, is equal to 0, right? And then I say while var student is not equal to Yeah, while var student is not equal to calendar, I'm going to print this. But what am I doing first? I'm going to first of all print the student at this index, var index, right? When I print the student at var index, what I want to do is I'm going to say var index is equal to var index plus 1. So I'm adding 1 to the var index, right? And then I'm going to equate var student to be equal to, I'm going to equate var student to be equal to the index at CSC 6741, I think this will work, 741 student. And then I say var index. Right, so if you notice, what I've done is I've created a while loop and I'm looping. So I loop, I print Aaron, I print Abel, I print Alex, Alfred, David, Davis, Dewin, DePaul, Emmanuel, Hendricks, Aiden, James, John. And it turns out that Kalenga probably comes after John. When I print John here, where is John? I don't know. But it's online also. When I print John, following John is Kalenga, right? So the moment I print John, I will get out of this loop because now the person I'm about to print is equal to Kalenga, is it? And my condition here, I'm saying I am going to continue looping here until until I find Kalenga, at which point I stop printing. And what you begin to notice, right, there are useful applications for this. Imagine you are reading a file, right? And I don't know if we're supposed to cover reading files. You say, I'm going to print what is in that file until I get to the end of the file. So you use a while loop actually. So print until you get to the end of the file. There's usually a marker that is at the end of the file or something like that. Anyways, so that's a while loop, I guess, or something like that. So you're repeating. I'm just showcasing the output for this while loop here. Took a while here for us to build the logic. In programming, there is such a thing as you need to plan, right? You write pseudocode first, especially as you're getting started here. You just don't write programs like what I was doing. This is horrible. It's almost like I'm thinking and I'm writing the code itself. You need to strategize first, and you write a heuristic and all those things. Easier that way. Anyways, so it turns out that with a while loop, you can actually break. Right? In some instances, you can break out of the loop, okay? So that you exit out. Let's say if a condition is met, just say I want to exit when this happens, okay? This is actually both in a for loop and while loop, right? You can break out, or when you find a certain value, you can say, I want to continue the loop and not proceed with the remainder of the code ideally. So you're skipping the rest of the iteration. And there are instances where you might want to do that, by the way, right? If that makes sense here. I want to ask if there are questions. I see this is 2030. I'm transitioning to some other interaction. I don't know why I committed to transitioning to different interaction. But are there questions about this? Okay. Well, if there are no questions, thank you very much. I wanted to ask you, perhaps you can reach out to me as soon as you can, colleagues, and tell me when on Sunday. If you're agreeable, you can just do 17 to 20. Remember, we started late. I know it's my fault. I do apologize for that. I had no control over what was happening, but kindly asking if we can have session of what we were supposed to do in the first hour or so. It was less than an hour, I know, but so I can also be so available maybe at 14 on Sunday if you wish. So 14 or maybe 17 if you want, just for an hour, and then we'll be done. The goal is to finish off the data structures, I guess. I had plans today to finish off or at least to kind of start the discussion of data structures. So right after these condition statements and stuff, we're supposed to start going through tuples, lists, and dictionaries, right? Should be fine here. Okay, so if there are no questions, I'll wait for Mr. John here to reach out to me, and then yeah, please, you know, if you're doing this for the first time here, because at some point we have got to start thinking about the exam here, you want to practice these things, right? That's the only way these things will make sense. Memorizing will not, it's not going to cut it. It won't. Thank you. Good night. Hoping Mr. Mwene will not forget to let me know about Sunday. Thanks.
Good night. Thank you.
Now I'll let you know.
Ah, yes, you are very diligent. Thank you, sir.